Good afternoon, everyone. Again, as we are about to begin, we are going to read a few of the guidelines that you must remember throughout the program. They are as follows. Participants must always be muted for the speakers and hosts to be clearly heard, and participants should click raise hand before speaking up during the workshop proper.
And lastly, participants must have a working Jupyter notebook on their computers. We hope that you'll all honor these guidelines so that the program flows smoothly for everyone involved.
Once again, a very good afternoon to everyone, and welcome. I am Franchesca Tortoza from BS Physics 2-1.
And my name is Saure from BS Physics 3-1, and it is our pleasure to be the Masters of Ceremony for the Day 3 of Code Up, a Python and LaTeX workshop.
We would like to start this program through a short prayer led by Saure.
Okay, so let's bow our heads and feel the loving presence of our Lord God. In the name of the Father, and the Son, and the Holy Spirit. Amen. Dear Lord, Heavenly Father, we praise you for your great love. We thank you that we can enter your presence today. And we thank you for gathering all of us today in this important event. We ask for your guidance and blessing to the speakers, organizers, and participants, so that we can fully enjoy and learn new knowledge from this gathering. Through your intervention, grant us stable internet connection and working devices for the success of this event. Lastly, please grant good health, safety, and peace to all men. May we be filled with the fullness of God. We ask all of this in your name. Amen. In the name of the Father, the Son, the Holy Spirit.
Okay, now that we have had our prayer, first of all, good afternoon to my dear partner. You're looking very radiant today. How are you feeling?
Thank you, partner. Of course, I'm feeling great today. Since day one, we have been learning a lot of new things. And of course, wow, we're already on our third day of our workshop.
Okay, so congratulations to everyone who's made it this far. We learned the basics on day one, so now we are looking forward to learning a little bit more about the applications.
Yes. Oh, first, I also want to greet everyone from our Zoom participants and also for those who are watching on our Facebook Live. So, good afternoon.
Okay. So, what was that?
Okay.
So now, without further ado, it is an incredible honor to introduce to you our first speaker for this day. She is a third-year student of the Bachelor of Science in Physics at the Polytechnic University of the Philippines. She finished her secondary degree at the same university, and she is also a DOST-SEI Science and Technology undergraduate scholar. She has been since 2019, and in addition has also participated in the Regional Invention Contest and exhibits National Capital Region at the Department of Science and Technology in the Technological Institute of the Philippines in Quezon City last November 2019. Today, to teach us all about the basic physics problems in Python, let us all warmly welcome Miss Arianna Bianca Brosas with a virtual applause.
First screen na po ako.
Marami po ba kami maglaro? Ay, maaari po ba kami maglaro? Gabi na, maglalaro po kami. Kasali po kami sa laro.
Kita na po ba natin yung first slide po?
Yes po.
Yes po.
Okay. Thank you, Leia and Franchesca, our MCs for today's session.
Gabi na.
Aking video, ayan.
Alis na kayo.
Maraming salamat din PUP Physics Society for organizing this program for the whole week.
Di ba? Wala ka pang sagot. Ipon pa lang yan.
Magandang hapon sa ating lahat. Pagbati mula sa kasalukuyan kong kinaroroonan, ang probinsya ng Pangasinan. Ako si Arianna Bianca Brosas. Kadalasan ang tawag nila sa akin ay Ari Kung ano doon sa buong pangalan ko yung mas komportable kayong gamitin, go lang. Salamat sa paglalaan ng oras at sa pagkakataong makapagbahagi sa inyo ng mga natutunan namin nitong nagdaang taon. In this session, we will try to apply the things we've learned from the previous days of Code Up and see how it relates with the physics concepts we've tackled from our high school years up to our college years. In trying out new skills, it is important for us to actually start doing something on our own with some occasional help from others, of course. That's an advantage of using Python as our starting program. It makes the starting point more beginner-friendly, which motivates us to expand what we know. Then, along the way of actually trying, we will encounter some flaws of this programming tool. That's when we will study other programming tools and fill those gaps. For now, let's fuse the concepts of physics and Python. Short review on the concepts that were covered in the first day of the workshop, since these three will be frequently used in our session. First is the function. Here, the keyword def signals the start of the function, and it acts like the header. Then our identifier along with its parameters that makes this function different from the others. Next, return and print. They are not functions, but they are classified as statements. Return statement for the computer to know what to do with this function, while print statement is for the user to know what's going on with the program. In space or linear spacing has these parameters: start, stop, and num. Start and stop for the range of the given variable, then num is for us to decide the number of points to be plotted within the given range. These two options are just the same. It's up to you which option you use, but for me, I'll use the second one. Since this session involves a lot of graphs, this library will be very helpful. It enables us to create different visualizations of the specific concept that we are trying to study. Freely falling bodies. Our first topic for this session is a motion with nearly constant acceleration due to Earth's gravity. We've encountered this topic in our senior high school days, General Physics 1, and it was again discussed in our first year of college, Physics Fundamentals 1. Now let's watch an example of a free fall motion.
Magandang umaga po, Ma'am Alex. Binibining Perez, maaari po ba akong pumunta sa kanya? Salamat po sa inyo, Bining Santos. Hindi ko po sinasadya, bilang pasensya ka na. Paraan nga, nakaharap kayo. Tama dito si Anne. Binilhan ka ng nanay mo ng logo. Paalam na po. Maraming salamat po, nanay. Walang
That video clip is from the movie Alice in Wonderland, the 2010 remake. I recorded some time intervals from that clip so we can use it later in our first program. Nadidinig niyo pa po ba ako?
Yes po.
Thank you. Here's our challenge for the topic freely falling bodies. Using the recorded time, create a program that calculates the instantaneous position and velocity of Alice as she falls in the rabbit hole. The program should show her calculated position and velocity at time t after her fall, ignoring air resistance. Plot the position time graph and velocity time graph of a freely falling body. While falling in the rabbit hole, Alice bumps into some objects like the bookshelf and the piano. Complete our first challenge. Let's use these objects as our marking for the time intervals. Here we denoted time as t sub n order of the object's appearance in the video clip. Before we start, sure that you have an access to our copy-paste board while I'm transferring my screen to our coding area. Ayan, visible na po ba yung ating Jupyter Notebook?
Yes po.
You? Paki-check din yung ating copy-paste board. May nilagay na po ako doon na outline for our first program para po mas mabilis po tayo yung pag-copy and pag-paste ng gagawin natin po mamaya. Okay, let's start with the modules. Ito yung mga module na diniscuss din sa atin ni Kersey last session natin doon sa workshop na monthly. Itin lang din natin. So, okay, that as okay. Bale, ito yung mga kinematic equations na gagamitin natin para magawa natin yung challenges kanina na nag-flash doon sa ating slides. Bale, itong y para doon sa instantaneous position ni Alice, y naught para doon sa ating initial position, v naught y para doon sa ating initial velocity at t for time. Sub y para sa ating acceleration. Nahin na natin dito sa ating calculation cells, ating gravity. Bali, itong a sub y natin, ayun yung Earth's gravity natin dito sa calculation cell. Insert lang din natin yung value. And t sub 1, kanina doon sa pinakita nating summary ng time intervals, ang t sub 1 natin ay 8.48. Y sub 1 is 1/2 times t sub 1 is to t sub 1 is times t sub 1. Ayan, kung mapapansin nyo, hindi na natin sinama yung initial position tsaka yung initial velocity natin since pareho namang zero yung initial values nila. Kaya itong part lang na to, tapos ito yung nakalagay sa ating calculate cell. Yun naman yung print statement para doon sa second challenge natin. Kailangan daw makikita natin yung result kung ano man yung nangyayari doon sa ating cell. Itong ginagamit natin ngayon na string formatting mechanism is yung F-string na itinuro din sa atin noong first day ng ating workshop. Y is equal to 1, comma, then yung at magkakalimutan is equal to 1. Then yung unit, per second. Hindi pala na-exist tong ating position. Wait lang. Try natin i-run. Ayun, meron na tayong first output at t is equal to 8.48 seconds. Y is equal to negative 352.36 meters and velocity natin negative 83.1 meters per second. Bago tayo umusad din sa iba pang code, transfer ko muna to sa ating copy-paste board. Okay, nandun na yung module sa ating copy-paste board. Na lang calculate cell. Ayan. Check ko kung may mga naggamit na. Visible naman na yung code natin sa copy-paste board. Next na. Bale, doon sa mga susunod na time interval, same lang din yung gagawin natin. Natin tong code. Papalitan natin, ibis na t sub 1, magiging t sub 2. Tapos yung value ng t sub 2, 14.14. Ito rin sa ibang parts ng code. T sub. Ito rin sa ating if statement. Check ulit. Mukhang okay naman yung lumabas na values. Bali, ganun lang din yung gagawin natin sa mga susunod na time intervals. Idiretso ko na yung code. Nasa copy-paste board na natin yung first code natin for t sub 1. Gagawan lang natin ang modification sa value para umakma siya dun sa interval natin. Pero ipipaste ko na rin itong code natin from t sub 3 to t sub 6. Bago natin i-run, pat ko muna siya doon sa ating copy-paste board. Calculations. Ayan, nandun na yung values natin from t sub 2 hanggang t sub 6. Try natin i-run. Paki-check na lang po yung copy-paste board. Ayan. Bale, ito na yung mga nakuha nating values. Bago pala yun, gusto ko sana malaman kung maayos nyo bang naililipat yung codes natin from copy-paste board papunta sa sarili nyong notebook.
Yes po.
Thank you sa sumagot. Thumbs up din sa ibang participants kung maayos nating nagagawa bago tayo mag-proceed. Ayun, thank you sa mga nag-thumbs up. Sana same result yung nakukuha natin ngayon. Kapag may napansin kayong kakaiba dun sa result, punta lang ulit dun sa ating copy-paste board para makita natin yung working code natin. Bale, ayan, nagawa na natin yung first and second goal natin dun sa list of challenges. Gagawin naman natin is yung graph ng ating position over time at yung velocity over time. Okay, next na is yung paggamit natin ng function. Turn on t times t raised to Tapos same lang din doon sa ating velocity. Palitan lang din natin yung identifier niya para palito yung ating mamaya. Tapos syempre yung mismo para doon sa ating return statement. Ayan, mukhang okay naman. Natin kakalimutan ilagay itong column na to. Hindi natin siya nilagay. Wait lang. Try natin ulit. Ayun, hindi mag-automatically na mag-indent yung return statement natin. Tapos, hindi rin siya gagana. Kaya wag kakalimutan ilagay part na yun ng code. Run na natin ito. Ayun naman yung mismong pagpa-plot natin ng ating position over time graph. T is equal to NT dot space. Puro gawin natin 0 from, balik tayo doon sa ating data. Yung last recorded time natin is 44.06 seconds. Gawin na natin 45 dito sa ating time. Next. Position. Negative 9.8 net, gravity third. Tapos yung parameter nating time. Balit itong line 4 natin dito sa kasalukuyan cell na ginagamit natin, parang yan yung line na nag-a-assign kung anong mga functions or parameters yung ilalagay natin sa x-axis or sa y-axis. Dito sa ating code, yung time is yung x-axis. Tapos yung kung ano man makukompute ng ating cell na to doon sa position natin, ayun naman yung mailalagay doon sa ating y-axis. Bago yan, pag-add tayo ng label. Y-axis natin, position. Then unit meters. Time. Seconds. Try ko muna i-run. Okay siya. Ililipat ko ulit sa ating copy board. Then may mali. Ano daw? NT, it's not fine. NP at lens space. Space. Iba natin na. Okay. Hindi pala natin na-run yung modules. Sorry guys. Okay, run ko muna. Kaya pala hindi gumana. Okay. Ayan, gumana na siya. Okay, ito yung first graph natin, position over time. Lilipat na natin siya doon sa ating copy-paste board. Unang equations. Saan na yun? Equations. Tama ba? Ayan. Next is ito, position over time na cell. Okay, pakicheck na lang po ulit yung copy-paste board natin. Nandun na yung code for equation cell tsaka yung position over time cell. Next is yung ating velocity over time na graph. Ayun, kinopy ko lang din yung code natin dito sa cell na to. Palitan natin yung nasa y-axis, gawin nating velocity. Since ayun yung identifier natin para doon sa function, nagko-compute ng ating velocity. Okay na ba? Ayun, yung label pala, papalitan din. Velocity meters per second. Try natin yan. Medyo nakakalito sa tingnan kapag katabi sila ng ating position time graph. Try natin baguhin yung kulay ng mismong curve. Gawin nating red siguro to. Or pwede niyong gawing ibang kulay. Kayo bahala kung ano mas gusto niyo. Bali dito ko siya inad sa line 4 natin. C is equal to R. Bali red. Sabihin yan. Ayun, meron na tayong velocity time graph. Lipat ko muna ito sa ating copy-paste board. Ano yung copy-paste board? Ayun, wait. Sorry, nawawala. Ayan, lipat na ba? Paano namang nalipat na guys? Paki-check na lang yung ating copy-paste board. Okay, tapos na tayo sa mga challenges natin. For 3D polling bodies na topic. Bago tayo mag-move on or bumalik doon sa slides, gusto ko muna sanang ma-check kung nasundan ba natin yung mga outputs na na-print natin. Thumbs up naman dyan, guys. Saan na yun? Yun, nakikita ko na siya. Ayun, may wala na nag-thumbs up. Siyam na, okay. Buti naman may nakasunod. Thank you, guys. Move on na tayo sa ating second topic. Palitan ko lang tong screen natin. Saan na ba yun? Ito. Nakikita na po ba ulit yung slide number 9 natin dun sa PowerPoint?
Yes po.
Thank you po. So, okay. Visible pa rin po ba? May ginawa po akong changes eh. Yung mismong slide lang.
Yes po.
Kita
Ayun,
po.
thank you. Thank you sa laging pagsagot. Next slide na tayo. Let's do a run through the program we've made to complete our challenges. The variable g and its value is particularly typed first to set all of g in this cell to be equal to the Earth's gravity. The negative sign indicating that we are dealing with downward motion. T sub 1 holds the value for the recorded time from the video clip. Then we did the equation for the position and velocity. Forward slash is used for division, single asterisk for multiplication, and double asterisk for the exponent. The parentheses here remain as a grouping symbol. Next is the printing statement. Remember that the arrangement of the string is up to you. Whether you follow a specific instruction or you have the autonomy to decide, it is part of the program, then you choose. We indicated that the output should be rounded into decimal places. Ito yun, yung part ng code. The calculation cell works this way by inserting the values for the known variables g and t. Y sub 1 calculates the position, then it will be printed in our output. Same process happens with the velocity. Next is the equation cell. Ito na tayo. The equation cell acts like the main source of our values for the y-axis. Notice that the equation we use in the calculation cell is same with the return statement of the equation cell. Bale, dito sa equation cell natin, pwede rin namang i-diretso na natin ng ganito, tapos wala na itong equation cell. Diretso na tayo dito sa position over time, velocity over time. Pero, kapag ang downside nun, kapag may mga babaguhin tayong variables doon sa ating equation, kailangan natin isa-isahin ulit yung cells. Pero kapag gagamit tayo ng separate cell para doon sa function natin, na magpapagana doon sa plots natin, mas magiging mabilis yung pagbabago ng mga variables or values kumpara doon sa idediretso natin ganito sa calculation cell. Tsaka kapag gano'n din yung ginawa natin, mas madali nating ma-determine yung mga error, mas makakapag-debug tayo ng mas maayos. Kaya, ayun. Pero kung gusto niyo i-try yung alternative method, pwede rin. Wala naman siyang effect dun sa mismong output, same lang din naman. That is the cells for the actual plots. Look at the argument in our space, we denoted the start and stop values. This depends on your specific target. Base the stop value in the last recorded time from the video clip when Alice reached the ground. Then we stated which variables or functions correspond with either of the axes. Same thing happened in the velocity over time cell. The different function for the y-axis, binago din natin yung color ng curve. Tapos, syempre yung labels, pabaguhin din. Siguro yun na yun. Okay. That's it for the freely falling bodies. Again, just check our copy-paste board if you want to review some parts of the code. Mamaya pala yung copy-paste board natin, tatanggalin ko na yung freely falling bodies na part para makapag-focus tayo dun sa next topic. Kaya habang nandito pa tayo sa slides ng next topic, kailangan niyo yung part na yun, pakikopya na rin. Maya-maya itatanggalin na natin. Palitan natin yung ibang codes. Okay, naririnig pa ba ako guys? Baka medyo nag-unstable yung internet ko eh.
Naririnig, pero minsan po choppy.
Siguro i-stop ko muna yung video ko para yung gaano mag-unstable yung internet. Yan. Try ko ibalik ulit mamaya kapag medyo okay na yung internet namin. Thank you pala sa pagsagot. Thank you. Okay. Simple harmonic motion. The second topic is covered in Physics Fundamentals 2, first year, second sem, Mechanics, discussed under periodic motion. Application of this concept ranges from clocks with working pendulum to the life-saving mechanism of shock absorbers in vehicular, shock absorbers equipped in cars. Tama. Here is a classic example of a simple harmonic motion. A mass attached to a spring. We can see that when the spring pulls the mass to the left, the starting force goes against this direction, as shown in the arrowhead pointing to the right. When the spring pushes the mass towards the right direction, the starting force points opposite to this direction. As we observe, the starting force aims to restore the system to its equilibrium position, wherein the net force is zero. When the restoring force is directly proportional to the displacement from equilibrium, the repeating motion or oscillation is called simple harmonic motion. The dotted curve here exhibits the displacement of the mass as it undergoes simple harmonic motion. Weight installed simple harmonic oscillators always has been. Nabanggit sa akin ng aming advisor na itong simple harmonic oscillators daw, maraming beses natin siya ma-encounter, yung mismong mechanism behind simple harmonic oscillator. Kaya all throughout ng ating journey as physics students, mas okay na mapag-aralan na natin pa maaga since makikita natin same concepts ng maraming beses every year. Our next challenge is to plot the position time graph of a simple harmonic motion with varying force constant, mass, and amplitude. Bago yun, please prepare your Jupyter notebook and make sure that you have an access to our copy-paste board. Okay, lipat na tayo dun sa Jupyter. Saan na ba yung Jupyter? Wait lang, mali. Dapat pala exit ko muna itong ating slide. Ayan. Turn na ulit. Saan na yun? Oh. Nakita na yung ating Jupyter. Stop. So Doon pala sa ating copy-paste board, tatanggalin ko na yung ating freely falling bodies na part. Papalit ko na yung outline ng simple harmonic motion. Wait lang. Outline niya. Motion. Ayun. Paki-check na lang din guys kung napalitan na yung ating outline dun sa copy-paste board. Proceed na tayo sa ating next challenge. Ayan, simple harmonic motion. Bali, ito yung gagamitin nating equation para dun sa ating simple harmonic motion. X for position, for amplitude, for time, K for force constant, M for mass. Start na tayo sa ating function. Function A. Lagyan na natin yung ating A asterisk and P that cosine. And time pala mo. P that square root K over M. Yung gagamitin nating function mamaya dun sa ating mga graphs. Tanda natin. Ito na tayo sa ating first graph. Single curve. Graph ng ating simple harmonic motion. E is equal to NP dot din space 2,50. Actually, ito sa T, pwedeng kahit anong number, pero ayun, trinay ko na yung ibang range. Feeling ko mas makikita natin yung simple harmonic motion kapag itong range lang. Pero try nyo pa rin i-adjust, guys. NP dot T, position ulit. Tapos, set natin ang 4 na lang muna lahat ng parameters para di nakalito. Then, try natin siyang i-run. Ay, na-run na ba? Equation 1? Okay, na-run. Ito yung single curve graph natin for simple harmonic motion. And pag zoom in ko, sana kita yung yung bumps dun sa curve. Hindi siya ganun ka-smooth. Katulad na nakikita natin sa textbook. Ayan. Ayun, may mga visible bumps siya. Try natin next slide yung ating code. Kung maalala nyo kanina dun sa first part ng discussion natin, meron pang isang dan natin to, 180. Bali, kanina kasi dun sa initial graph natin, ito, maraming bumps sa curve. Automatic yun kapag di ka nag-enter ng value sa num, 50 points yung ilalagay niyang division doon sa range na nilagay mo. Bale, doon sa nakita nating result, hindi enough yung 50 divisions na yun. So, increase natin ng 180. Try natin run yung... Ayan. Mas naging smooth na yung ating curve. Puro lagyan natin ng... Yun, ang next natin gagawin, kung titingnan nyo yung mga examples dun sa University Physics na book, medyo kakaiba yung graph ni simple harmonic motion doon. Yung parang yung style ng mismong graph. Pero okay naman yung curve natin, yung style lang. Try nating baguhin para mas maging hawig siya dun sa examples natin sa libro. So, natin, lagay pala muna ng limit doon sa ating y-axis. Kasi mamaya, increase din natin yung ating amplitude. So, preparation na yun. Tapos, itong modification dun sa mismong itsura ng graph, dediretso ko na yung code niya since medyo mahaba at mabagal po akong mag-type. Pasensya na po. Ayan, pero explain ko naman siya. Bale, bago natin i-run, itong part na to, yung top tsaka yung right, parang sinet niya yung color nung itong border natin sa none. Parang wala talagang kulay para mawala tong border natin. Tapos yung left na line, tapos itong bottom na line, pag isahin niya yung y-axis natin tsaka yung x-axis natin in terms of dun sa starting point, parang itong border na to, ilalagay niya dyan sa may origin, sa 0. Para ano tayong division sa positive side tsaka negative side ng ating graph. Try na natin siyang i-run. Bago pala yun yung labels, di ko pala na-discuss, no? Itong labels, i-run muna natin. Bago natin discuss pala. Ayan. Ayan na yung naging graph natin after nung mga naidagdag nating setting doon sa ating code. Kung mapapansin nyo yung label, meron tayong font weight, ginawa nating boldface para mas makita siya mamaya doon sa graphs. Regardless kung gaano karami mang curve ilagay natin, siya masapawan ng iba nating elements doon sa graph. Font size 14, ayun, yung reason. Location, doon sa y-axis natin, nilagay natin sa taas. Sa x-axis naman, sa right natin lagay. Kasi kung hahayaan natin na yung usual setting, nasa gitna tong label natin ng time, mamaya matatabo na siya ng ibang curve. So, ilagay natin dito sa bandang kanan. Rotation nitong x, label, flip ko lang yan, yung 180 na rotation. Pero pwede nyo namang gawing landscape version. Parang mas okay lang sa akin na makita siyang naka-portrait. Pero hindi naman necessary to guys. Kung anong trip nyo gawin, go lang. At bago tayo mag-move on, copy-paste board pala muna. Ayun, yung equation pala muna. Yan, nandun na yung code natin sa copy-paste board. Pa-check na lang po. Bago tayo mag-graph ng iba pang values natin, gusto ko sana makita kung nasusundan po ba itong single curve graph natin ng simple harmonic motion. Ayun, may isa nang nag-thumbs up. Yan, dumadami na. Mukhang may mga nakakasunod naman. Thank you po. Kung na tayo, konti na lang ata yung time. Okay, multiple curves. Multiple curves na. Ano yung first constant? Ayun, first constant. K muna yung babaguhin. Bali, kinopya ko lang to. Yung code natin dito, nilagay ko lang dito. Tapos, mag-add lang tayo ng iba pang curves para mas makita natin kung anong epekto ng pagbabagong ginawa doon sa value ng force constant. Ito, yung binago kong value is yung third parameter doon sa ating position function. Kung gusto nyo balikan ulit, ito lang yun. Bali, itong K, pangatlo yung babaguhin natin. Tapos label. Yan natin label para di nakakalito mamaya. K is equal to 5. So, yung ibang changes, guys, i-paste ko na lang diretso para hindi tayo matagalan dito sa part nito. Same lang din naman. Nalagay ko rin sa ating copy-paste board. Ayun, bale, dun sa values ng K, makikita natin na yung first curve, 5, yung value ng K niya, tapos second curve, 7, tapos yung third curve natin, 9. Try nating i-run. Ito yung ating result. Parang may kakaiba. Medyo crowded niya. Gawin natin to. Natin tong range natin ng time. Gawin natin siguro ng 12. Ayan, mas okay. Bago pala yun, lagay natin sa copy-paste board. Ano yung copy-paste? Ganun. Varying force constant. Yan, available na po sa copy-paste board yung code. Next, varying mass. Same code pa rin. Set lang natin ulit itong force constant sa core, lahat ng curves. Tapos, ulit yung mass. Also, itong pang-apat. Pang-apat na parameter. Ito 10. Natin siguro. Tapos, 14. Sa labels, baguhin natin. As na siya. 10 kg. Ayun guys, SI units yung mga ginagamit natin all throughout ng course. Ayan, ito naman yung sa ating varying mass na graph. Change din natin yung ating range dun sa time para mas makita. Yan. Mas kita na siya. Lagay ko ulit siya sa copy-paste board natin. Saan na yun? Varying mass. Ay, available na po doon. Next, varying amplitude. Kaya diretso ko na guys. Baka namin tayo sa oras sa mga susunod na topic. Pero yun, explain ko din naman para dito sa varying mass natin, nakaset yung amplitude at force constant sa 4. Pinagbabago natin yung mass. Dito, 4 naman yung values ng ating force constant at mass. Ginawa natin ang changes ay yung ating amplitude. Run na rin natin ito. Ayan. Tama ba yung sinet nating range? Ayan, okay naman. Lagay ko na ito sa ating copy-paste board. Varying amplitude. Pa-check na lang po ulit ng copy-paste board para dun sa code. Ngayon, bago tayo mag-move on sa ibabang topics, observe po na tayo. Kung mapapansin natin dito sa ating varying force constant na graph, habang ini-increase natin yung force, mas nagiging maikli yung ating wavelength kung sa ating graph. Mapapansin nyo, iba yung wavelength ni blue curve natin para dun sa ating green curve. Green curve na may pinakamataas na value ng force constant, mas maikli yung ating wavelength. Ayun yung observation sa ngayon. Mamaya, mas ipapaliwanag natin ng mas maigi. Ayun, tingnan lang natin, observe lang kung ano yung mga nakikita natin dun sa curves. Baliktad naman dito sa ating mass. Habang i-increase natin yung mass, mas nagiging mahaba yung ating wavelength. Opposite siya na nangyari dito sa ating force constant. Pag titingnan mo naman yung amplitude, same siya ng wavelength per curve, pero yung napansin nating pagbabago ay yung distance ng ating paggalaw ng mismong mass na connected dun sa ating spring. Yan. Mapapansin natin yan dun sa values ng ating y-axis. So, same siya ng wavelength. Ang talaga siya nagkaiba sa previous graphs natin. Bago tayo bumalik dun sa slides, Check muna natin yung participants. Nakakasunod pa po ba? Thumbs up naman po. Kung nakakasunod. Ayun, mukhang madami namang nakakasunod. Thank you po. Attention na po, medyo napaspasan ko na siya. Sorry. Next is yung ating... balik muna tayo sa slide pala. Visible na po ba ulit yung slide?
Yes po.
Thank you po. Ayan po, visible pa rin po ba?
Yes po.
Ayan, thank you. Medyo nag-unstable ulit yung net. Ayan, paalala lang ulit guys. Mamaya, buburahin ulit natin yung harmonic motion na codes dun sa copy-paste board. Kaya habang discuss natin itong next topic, yung review pala muna, pakikopya na po. Pinado sa board natin. Okay, review. Equation 1 cell contains our function with its return statement for the y-axis of our graphs. Next is the initial parameter cell. We reviewed the concept of bin space and implemented some modifications to produce a graph that is for the varying parameters with multiple curves that follows the same system as that of the initial setup. Bali, parang ito lang yung mga cells na may distinct na pagkakaiba sa isa't isa. The rest ng cells natin, same system na rin yung pinapagana dun sa ating varying constant na cell. Okay, ito nang next. Ang oras na ba? Okay. Our last topic for this session is the double slit experiment. It is part of the discussion for Physics Fundamentals for second year, second sem. In 1672, Isaac Newton elaborated the theory that light is a particle, but it cannot explain the diffraction, and the interference of light. In 1609, Christian Huygens published the mathematical wave theory of light. It predicted that waves could interfere with each other. In 1801, Thomas Young performed the single-slit experiment, then published the double-slit version of the same interference experiment in 1807. Bale, ito po yung mechanism ng double-slit experiment. May monochromatic light dadaan sa slits, then magpo-project ng fringes, bright and dark sa ating screen. Next, doon sa wave property ng ating light, mapapansin nyo dun sa slits, may dalawang semicircular waves. Tapos, ang nangyayari doon, meron tayong constructive interference na nagpo-produce ng ating bright fringes. Tapos, destructive interference naman para dun sa ating dark fringes. Ayun, itong topic na to, known for its dilemma as an experiment wherein just by simply looking at some pages. Ayun, yung sentiment ng pusa, gugustuhin ko maging part ng double slit experiment, papamaan ka ng monochromatic light, kaysa naman ilagay ka sa code, tapos di pa sure kung buhay ka, ganun. Next, for our challenge, let's be familiar with the symbols we will be using in the code. The light source is wavelength is denote X, DMZ, acronym for distance from zero, parang distance from bright fringe. And the projected result denotes the location of the bright and dark fringes. Tapos, itong A natin, slit width. Tapos, D, slit separation. Challenges. Hello po. Sorry, medyo na-disconnect kanina. Nakabalik na po pa ulit ako.
Yes po, naririnig ka
Ayan.
po.
Pero dumiretso na tayo sa ating Jupyter notebook. Ayan. Okay, visible Jupyter notebook natin. Pagpagin ko na ulit sa ating board. Lalagay ko na yung outline natin for this experiment. Ayan. Check na lang po sa copy-paste board kung visible na yung outline natin for double slit experiment bago tayo mag-start. Okay, start na tayo. Bale, ito yung equation natin for the
Okay, seems that our speaker was disconnected. Let us wait for her.
sorry po, medyo, ayan, na talaga yung net namin ng ganitong oras. Balik ko na lang sa
Yes. So while we are waiting for our speaker to connect, I'll ask my partner. Hi, Franchesca.
Hello.
Hello. Yes. So how are you feeling after the discussion?
I'm a bit overwhelmed.
Oh, yes.
I just
yes. Oh,
finished
actually-
first year. I have never seen the double slit equation before.
Oh, yes, yes. So I think just the same as you. Of course, some of the first years are also feeling overwhelmed as well, right?
Probably so.
Mm.
Apologies to the first years. We feel the same.
Yeah, so well, yeah, so while we are waiting, so I'm also going to ask some first year, some first years, so maybe can the first years give me a thumbs up react or heart react? Oh,
Where are they?
where are they? Oh, I think they're afraid of us asking them. Oh, so we have one here. So it's Prasha Abraham. Yes. Hello.
Hello.
Oh, so Miss Arianna is here.
Hi.
Okay, so
sana bumalik na yung internet namin, please. Ayan, share screen ko na ulit.
Hello.
Disabled po yung share screen power ko. Ano na lang po.
yes. So let's continue.
Ayan, okay. Thank you talaga sa paghihintay. Saan na ba? Ayan. Kita na po ba?
Yes po, nakikita po.
Yung share ko pong Jupyter notebook. Yes. Bale,
Yes po,
ayan guys.
visible
Hindi ko na
po.
siya isa-isahin. Pakita ko na lang yung result. Dun sa ating varying slit separation, ito yung first na result natin. Thank you. Ito yung first result natin. Ilalagay ko ito mamaya sa ating copy-paste board lahat. Discuss na lang din natin. Ito yung next result natin nung ginawa nating 0.1 yung ating slit separation. Tapos, ito naman yung ating third result. Yung last graph sana natin, ganito yung maging itsura. Bale, based na yung separation, ang binago-bago natin dito ay yung kulay, yung monochromatic light na tumatama doon sa ating double slit. Kaya nagpa-project siya iba't ibang kulay din sa ating screen. Wait lang guys, ilalagay ko siya sa copy-paste board. Ayan, para ma-run nyo rin. Ito na po. Equation na lagay ko na. Ito na lang.
Unfortunately, our speaker was disconnected one more time. Yes. Actually, at this time, I see that yes, there's a lot of people who are having problems with their internet connection, right, Franchesca?
Yes, yes, I see that as well. I'm having trouble on my end as well, but evidently it's not as bad as our speaker's problems.
Yes.
What am I hearing? So the equation is up on the copy paste board in case anyone wants to mess around with it while we're waiting for a speaker to come back.
Yes. So how about you, partner? Did you try inputting it to the
I've inputted
Jupyter?
it. I have inputted it, but I've not tried calling the function because I'm not sure what any of these symbols mean.
Actually, I've also tried, but yes, I think there's still no
Nope, no
So
context.
po,
yes.
na-connected
Hello.
na ako this time.
Hello.
Po, okay. Diretso na natin dun sa ating PPT. Baka mag-disconnect ulit ako. Ayan. Bale, dun sa code natin mamaya, send ko na lang din. Punta na tayo sa ikatlong ng ginawa natin for this session. Slide. Ito na po ba? Calling objects po na slide. Connected po ba po ako?
Hello, pero
Hello
nasa
po.
challenge.
Kita po ba yung ating slide?
Nasa challenge slide po yung nakikita ko sa screen. Now, nasa review na po. Oh. Yeah, sadly, our speaker was disconnected.
Ayun guys, sorry. Magde-decide na ako na siguro, i-decide ko na mag-stop muna ako dito. Sisend ko na lang yung PPT natin, tsaka yung mismong notebook sa GC. Pasensya na po ulit sa interruptions po. Yun. Narinig po ba yun?
Yes po.
Yes, thank you.
Ayun, thank you. Pasensya na po ulit. I-send ko na lang din sa GC yung code natin, lahat ng topics, tapos itong explanation per result. Ayun, maraming salamat, PUP Physics Society at Computational Physics Group. At salamat din sa patience at pakikinig sa akin. Thank you guys. Sorry ulit. Thank you po.
Yes, thank you, Ms. Arianna, for that interesting discussion. Sadly, there are some there are some internet connection problems, but I'm sure that a lot of our participants, of course, learned uh, learned in your discussion. Thank you, Miss Arianna. Yeah, so yeah, so with that, maybe if yes, maybe if there are any questions that you would like to ask to Arianna, please click the raise hand button and wait for us to call your name. So you may also state any takeaways you have had while listening to the discussion. So, so are there any participants who have questions to Arianna?
Ayan guys, madami tayong takal na part. So, ayun.
Yes.
Sana connected na ako hanggang mamaya. Ayun. Questions po?
Yes.
Meron na.
Oh, actually, ako po may question po ako. Yeah, so
Ayun,
actually,
Yagi,
yes.
question.
Yes. So, so meron tayong free fall and then the oscillation. So I think meron pa bang mga other basic physics problem na you recommend for us to explore on our own?
Siguro sa na-discuss natin physics funda 1, physics funda 2, physics funda 4. Siguro try natin dun sa physics fundamentals 3. Ayun, mga charges, ganyan. Try natin i-apply dun yung mga natutunan nating Python codes. Tapos tingnan natin kung yung mga graphs ba na nakikita natin dun sa libro, kaya ba natin siyang i-replicate gamit yung mga codes natin sa Python. Yung mga examples ko kanina actually, galing din siya dun sa University Physics na group. Tinignan ko lang yung mga graphs dun. Masubukan nga kung magagawa natin siya sa Python. Ayun, nakapag-produce naman tayo ng mga graphs. Doon lang sa mga parts na walang specific value. Siyempre, mahilig yung book sa ganun yung letters lang. Tapos, bahala ka maglagay ng values. Ayan.
True.
Bali, kayo na bahala dun. Siyempre, lalagyan niyo ng mga test values. Tapos, kapag binago-bago niyo yung test values na yun, makikita niyo na may effect. Ay, ito may epekto sa ganitong part ng ating specific law sa physics. Ganun. Para makapag-practice, ayun, buklatin lang yung University Physics na libro, hanap ng graph doon, try natin gawin sa Python. Ganun lang.
Oh, wow. So I think I would like to try it on my free time. Right. Oh, how about you, partner? Oh,
I actually had a question of my own, but I'm not sure if anyone else wants to ask a question before I go.
oh, actually, there's a question on the chat box, so maybe I will read.
Oh, yes.
Okay, from Rajan Estabilio, parehas lang po ba gamit ng apostrophe at quotation marks? Madalas na pagpapalit ko po kasi pero wala naman pong differences.
Wait lang. Mute pala ako.
Okay na po. Ngayon.
Walang difference sa'yo. So, bali same output pa rin, ano, Rajan? Kadalasan kasi ginagamit siya dun sa part ng sa label. So, kaya maglalagay ka ng mga modification or specific setting dun sa mga variables na nilalagay natin. Siguro kung wala namang changes, okay lang din siguro. Pero yun, hindi ako gaano familiar kung kailangan ba talagang ganun lang yung gamitin natin. Ayun. Lang muna siguro. Thank you, Rajan.
Okay, if that was it, we actually have received another question from Lovely Rose Cruz. She says, Ate, dahil po programming siya, kaya po ba ng Python gumawa ng simulations, lalo na po sa physics? Example po yung mga PhET simulations that we're all too familiar with.
Feeling ko kaya naman. Nandun siya doon sa description ng Python eh. Pero ayun, hindi ko pa siya din natatry. Siguro ginagawa ni Kersey doon sa icing model na may animation na siya. Parang familiar siya dun sa concept nung sinasabi niyang simulations. Ayun. Yung capability ng Python for simulations. Ayun, si Kuya Steven, nagtataas ng kamay.
So sa Python, kaya mong mag-simulate ng marami, especially sa physics. So fun fact, pwede ka mag-simulate ng isang Schwarzschild black hole sa Python. Pwede mo i-search mo lang sa net, then pwede ka na mag-simulate ng isang black hole sa programming sa Python.
Okay, so are there anyone who would also like to ask questions? Mhm.
If I may answer, actually. To the person who asked if you can make simulations in Python, I've actually heard of the module, or I'm not sure if it's a modular extension called VPython, which I have seen to be used in 3D modeling and 3D simulations. So if you're interested, try looking into that program. Module?
Yes. Okay. Oh, so Franchesca, you said earlier that you have a question. Would you like to ask it to Arianna?
All right, if we're still entertaining questions. I actually wanted to ask if there were other ways of plotting that are found in Matplotlib. Is that what it's called? If there are other ways of plotting there besides just line plots, and how they might be useful in physics specifically.
Ayun, madaming iba't ibang graphs na magagawa natin dun sa module na yun. Actually, may discuss siya dun sa day 5 ng ating Python workshop. Different visualizations pa. Bukod dun sa ginagawa natin ngayon. Parang sumentro lang yung araw ngayon dun sa mga physics problems na aware tayong lahat, undergrad students. Kaya kung gusto niyo iba pang visualization na kaya ng Python, abangan niyo yung discussion sa Friday.
Thank you very much. Well, in that case, I'm very much looking forward to Friday then. Does anyone else have any questions? Or can we move forward to asking you?
Ayun, yung ano pala guys, habang naghihintay, baka meron pang may question dyan. Yung sa double slit experiment natin kanina, pwede rin, ang baguhin nyo doon is yung slit width. Bukod pa dun sa separation na ginawa natin dun sa mismong code, makikita nyo na yung difference niya from slit separation to slit width is visible din compared dun sa mga initial na parameters na sinet natin dun sa experiment. Para mas makita natin yung wave nature ng light. Ayun.
Okay, so it looks like we've covered all of our questions. Yes, so however, it's time for a 10-minute break, I think. Yeah, so let's have a short break before we continue the program. So I think we're still halfway. Yes, halfway from the program. Yes. Okay, so Franchesca, hello.
Hello.
Hello, yeah. So maybe would you like to ask some questions to our participants?
Participants.
Yes.
Who shall be our victims?
Yeah, so who would you like to pick?
All right, I'm going to try picking some of my classmates. Before I call them, fine. I will ask the question. My first question would be, especially because we've got freshmen involved and even seniors involved, to anyone who is not my classmates, to anyone who's just in second year, now that we've finished our first year of BS Physics, how are you finding the experience, and has it changed how you look at physical processes, or is it just not? I'm gonna ask our dearest class president, Rex Vincent Leyva.
Go Rex.
Answer me.
Hello po.
Hello.
Sorry. Ano po ulit yung question? Sorry.
The question is, how are you finding, well, college education after a year of being in BS Physics, and has it Has it changed your outlook on anything, or is it just a school subject?
Marami pong changes, to be honest. And, wait lang. Sorry, hindi po ako ready para dito.
Hello.
So, ayun,
Neither are
feeling
we.
ko, feeling ko marami na pong changes, lalo sa perspective ko as a college student din sa PS Physics. And isa po sa mga natutunan ko rin is yung mga skills, like halimbawa leadership skills po and yung pagka-communicate or socialization din po sa other peaks. Yun lang po. Thank you.
Okay, thank you for your answer. How about you, Leia? Is there anyone you want to call on? Anyone you want to ask?
Yes. Yes. Oh, actually, I would like to greet and also ask questions to our first year. Yeah. So actually, earlier I see that uh which one? Okay, I see that one. Yes, I asked them to give me a thumbs up, but I think yes, they're shy to answer me. So I asked our my friend Lovely to tell me who are the first years. um, yes, in our program. So I think let's have Prosha Abraham. Hello, Prosha Abraham.
Sorry po kanina misunderstood ko po. Second year na pala ako.
Oh, oh, sorry. Okay, yes. So because I saw
Sige po.
you earlier, yes, you gave me a thumbs up. Okay, so maybe, mm, yeah. So let's have, um, okay. So let's pick one from the first years. Mm, Jamaica, is Jamaica first a freshman? Yes. Yes, is Jamaica a freshman? Hello. Mhm. Oh, I think partner. I think our first years are yes are very shy to answer
Little
our
shy.
yes. Oh, so maybe I'll just ask you. So maybe first yes the classic question. So why did you choose physics?
Initially, I actually chose physics with the intention to go into secondary education as a postgrad uh, program because I found in high school teachers were not very good at teaching physics, math, calculus in a way that students enjoyed. But I still enjoyed the subject, so I figured I could go into secondary education and help make more people comfortable with the idea of so-called difficult subjects like physics and chemistry and calculus. What about you?
Mhm. Oh, actually, before I was interested in atmospheric physics, so maybe until now, that's why I wanted to take this program. Yes. Oh, actually, someone gave me a name.
Oh,
So we have. Maybe can I call on Joseph? Joseph.
who might it be?
Hello, Joseph.
Hello
Are
po.
you? Hello. Yes. So again, the classic question. So why did you choose physics? Yes.
Pwede po ba mag-speak ng Tagalog?
Sure.
So,
Yes.
kaya ko po pinili yung physics kasi siya po yung isa sa mga pinaka-fundamental ng science na pwedeng magturo sa atin kung may mga extend pa ang universe po natin. Kasi nga po, di ba, masyado pong malawak ang siyensya, agham sa mundo po natin. Kaya kailangan po natin na-explore at marami po akong matututunan po ngayon na pwede ko pong i-apply sa real life ko po na ayun at gusto ko rin pong malaman kung totoo po ba yung mga parallel universe po na gano'n.
That is a very interesting reason.
Yes. And actually hindi pa kita papakawalan. May isa pa akong tanong. Joseph. So maybe so maybe yeah, so what will be what's your expectation um sa PUP and also sa ating physics society?
Nag-expect po ako ng a friendly society po, gaya nga po ng na-feel ko po ngayon sa mga seniors ko po, sa mga sophomore po, na tumutulong po sila sa mga gawain po namin na para bumahanap po namin yung mga professor po namin at yung mga kailangan po namin gawin sa susunod na po. At tinutulungan po nila kami sa makukuha po namin subject po sa mga susunod po pong pagkakataon. Sorry po sa voice, medyo kinakabahan.
Sorry then. Thank you, Joseph, for answering our questions. Yes, so so I think we still have 1 minute break. Of course, if any one of you are feeling sleepy or want to eat some snacks, yeah, so you may do so. Yes, and also I would like to call on Sir Nene if you have Sir, baka po may gusto po kayong sabihin.
Ayun, para akong nasa ano no, campus radio dahil ang gaganda ng mga boses niyo no.
Thank you
Alright.
po.
Thank you, sir.
Oo. Thank you very much dun sa ano pagpunta dito sa Python 2.0. So last year meron din ito no. Tapos ngayon ginawa na natin sana ano na to no, maging yearly. And this is really ano ginawa natin to dahil gusto nating ma-encourage yung mga student na mag-research. And kanina nag-isip ako doon sa sagot na ano yun no, yung pwede ba yung mga PhET? Tama ba? PhET yung tawag no. Kung hindi ako nagkamali, ito yung na physics demonstrations no sa virtually. So, pwede. Actually, mamaya magtuturo ako no. Meron akong mga kinode sa Python. No, siyempre yung mga estudyante ko hindi ko nasasabihin na ay ginawa to sa Python. Pero in order to visualize that, so ginagawa natin siya mga simulation. So one friendly tool is Python, lalo na kunwari may iba kasing mga tools sa physics na magpapakita rin ng simulation. Kagaya ng COMSOL, yan, medyo may bayad yan, COMSOL. Python walang bayad, so that's advantage. Pero kailangan para kang isipin mo, para kang nagle-Lego, no? Kunwari meron kang gustong i-build na house. So hanapin mo yung mga building blocks sa nagagamitin mo para ma-build mo yung Lego house mo. So ganun din sa Python. Kunwari may gusto kang i-simulate, hanapin mo yung mga building blocks sa Python para magawa mo yung project mo. And imagination is the limit. Yung sinasabi na, and of course, computing power, no? Baka mamaya yung computing power na kailangan mo ay sobrang laki. Ang data mo pala na gagawin ay thousands of terabytes. Baka hindi kakayanin yan ng ordinaryong laptop, no? Pero, well, ayun, pwede naman tayo mag-start small. So, kaya ito, sa Python tayo gumagawa on our PC or Mac. Simple lang, no? Yung mga kinocode natin ngayon. Pero don't worry, ganun naman talaga ang ginagawa natin sa research, no? Like, we start with simple things, with basic. Eventually niyan, magugulat ka na lang na, ay, ano na pala, ang layo na pala nung narating mo. Ano lang, slow is fast, small is big. Okay? Yun lang.
Yes, thank you po, Sir Nene, for that for that short speech for this program. So now let's continue our program. So now it is my pleasure to introduce to you all our second speaker for today. He is a graduating student of Bachelor of Science in Physics at the Polytechnic University of the Philippines, Manila. He's been an academic performance awardee and a certified lister since his freshman year. He attended various seminar trainings such as the Philippine Astronomical Society monthly meeting in 2018, Synchrotron and X-ray Laboratory in 2019, and Link Nayan physically bonded despite the distance in 2020. Above all, he is proficient in programming skills such as Python and MATLAB. So he will be discussing matrices in Python and application in physics. Let us all welcome Mr. Stephen Francis F. Udaundo with a virtual applause.
May I share my screen now?
Of course.
Can you see my screen now?
Yes.
Yes po.
Okay, so for the second part of the introduction to Python Day 3, I'm Steven Udaundo, and I will be showing you how matrices and applications in physics. So I focus on one application of matrices in physics. So our physics problem is, of course, optical multilayers. So optical multilayers are just stratified optical materials. So they have alternating refractive indexes or different refractive indexes. So they're just patong-patong lang sila na optical materials. So an application of optical multilayers is anti-reflection coating. So anti-reflection coatings has been used in solar cells to improve efficiency of devices. So as we can see here, they use an anti-reflective coating. And we also have another application of optical multilayers such as biomimicry. So there are many species that is observed that have optical multilayer reflectors in their cuticle. So as you can see in the picture, the Japanese jewel beetle, which has a beautiful color, which is actually caused by stratified optical materials. And we also have plasmonic sensors. So plasmonic sensors are very, very sensitive sensors. As you can see here by the research by Udin, they can detect COVID and they are just optical materials. So before we go into our physics problem, we first have to learn how to make matrices in Python. So you can see now my Jupyter screen.
Yes po.
Okay, so in our programming, we'll only use two modules, NumPy, for the mathematical functions needed, and matplotlib, pylab, matplotlib, as TLT. So I'll put a comment here. So module, okay, sorry, for plot. Let's just wait since my computer is very slow. Oh, I get it. Why it's there. There. So first, we have to make so we have to first learn how to make matrices using NumPy. So matrices is very familiar to us seniors from fourth year and third year, and second year you will encounter this in mathematical physics 1. So to make a matrix in using NumPy, so let's start first with a row matrix. So we use the NumPy function and array. So np array, then we make a bracket for the row. So simple as that, you put a list in the np array. So let's see if it, oops. Let's see if we, there. So as you can see, as we try to create this matrix, there, we can see that it printed the correct. Now for a column, oops, sorry. Now to make this one, each row actually consists of a bracket. So we have a bracket for the matrix and another bracket for the rows. 2 and 3. So if we print this, we get the column matrix. Now for a much more complicated, so we have a 3 by 2 matrix. So as before, we make a bracket for the main matrix. Then for each row, oops, sorry. One, two, three, 4, 5, 6. Then we run it. Let's see if we made the, as you can see, we have created the matrix for the 3 by 2 matrix. So in NumPy, there are also, and as we have made a matrix, we can also do operations of matrices in Python. So let's make our first matrix X empty dot array. So similar, or 3 by 2. And our second matrix, let's denote it as Y. Seven, 9, 10, 11, 12, and oops, sorry, 13. Now we can now do operations. Y. So let's see if we made our matrix. There, as you can see, adding these two matrices results in this matrix. Now we can also do subtraction, which shows us this matrix. Now the next operation that we're going to do is the dot product and the cross product. So let's make a 2 by 2 matrix first. For each row, one bracket, 1, 2, 3, 4. Since they are the same, just name this Y. Now to do a dot product, so we simply is equals np dot x. So let's see if we created the matrix. So that's the dot product of x and y. There's also another way to do dot product. So let's just x, our first matrix, dot and y. So let's just name this z2. Wait, we do this one. So there we can use this as to do the dot product. So to simply the other operation, the cross product, is simply change this. There. So that's the cross product. So now we know now how to do the matrices. So we now move to our physics problem. Can you please answer if you can see now the presentation?
Yes po.
Okay. Oh, by the way, I'm sorry. I forgot to paste it in the copy paste board. Now the matrix. And the operations. So you can now see the, have you seen already the copy paste board? Is the code already there in the copy paste board? Please thumbs up if it's already in the copy paste. Okay, there are few thumbs up. So now we focus on our, can you see my screen now? Oops.
Yes.
Okay. Oops. So now we're gonna do is we're gonna use matrices in very specific applications in physics. So in electrodynamics, third year you will know this in your second sem, the wave equations and the solutions to the differential equations. So, oops. So in an interface, there are two polarizations of light, and from there, the ratios of the amplitude of the electric fields is the reflection coefficient and the transmission coefficient. So from here, we can get the Fresnel equations. So the Fresnel equations are basically relating the reflected wave and the transmitted wave in a interface. So we can see that there is the p polarization and the s polarization. So let's go now to the, where is my code? So now we focus on the coding. So can you see my screen?
Yes po.
Okay, thank you. So first, we have to make the functions to make our lives easier in computing. So instead of putting np.cosine, so we can simply write cosine. So we can just call this function later. Return np.cosine of angle. Sine. As we can see, we need sine here and cosine. Oops. So we're doing this, guys, so that we won't use NP often. So we just made them function. So we just define a function. So we're gonna use the exponential later. And lastly, sine. Turn it up. Sine. And so I'm gonna send this to the copy paste. Oh, I forgot. Oops. So pi. Into that pi. So I'm gonna send this to the copy paste board. So now we can start making the Fresnel equations in Python. So we first define the reflection coefficient, which is the ratio of the reflected wave. So what we need here is, since we have two, we have a p polarization and an s polarization. So these are the modes. So we can put here mode. So we're gonna use an if else statement, which is taught by Kersey and Dahl in day one. So, and 0 from our diagram. So this is the first refractive index. So in a single interface, N0 and NL are basically the same. So NM, which is the transmitted the refractive index in the transmission side angle. Now we're gonna make the if and else statement. So if mode. So let's start first with the P polarization. So we get NM. To avoid errors in parentheses, it's much better if you prepare the parentheses firsthand, since there are many problems that arises when you miss a parenthesis, or sometimes the Python reads a problem differently if you don't use parentheses. So this is for a numerator and this is for the denominator. We get NM times cosine, since we already defined the function cosine, so we don't need to put NP here. Now, cosine. So to make it, so later we're gonna use this part. So we're gonna make it general. So we're gonna use Snell's law that you will learn in optics in our definition of our angle. So we make arc sine N0 NL. Wait, there may be problem if I did that. So yeah, times sine angle N0 over N. So in a single interface, basically NL and N0 and NN are basically equal. So this will just become equal to 1, and it will only become cosine of cosine times theta. Cosine and theta, sorry. And now the arc sine. So we have here minus, oops, that almost error there. So we can just copy this. So we can see NL times cosine of N. So basically change this and make this to the refractive index on the transmission side. Now, as you can observe, the difference here from the numerator and denominator is just the plus sign. So we can just simply copy the numerator. And simply add plus. Now we have for the P polarization. Now we use a elif for the other mode, which is the S polarization. So as we can observe, they just switch the refractive indexes. So here we can see that NL. Okay. Just basically copy this, and we can just simply change. So in S polarization NL, here we made it to M NL. And we can also put an error if there's an error, or if we miss writing the modes. So can write. Okay. Let's put here error. Now we can try to code the transmission coefficient, which is the T here. So they use the same parameters, so we can simply copy this. Oops. Simply write transmission. Now, like the reflection coefficient a while ago, we can we repeat the same process as we did with the okay. So as you can see, the numerator for the transmissions are equal to their counterpart denominators in the denominators are exactly the same as the denominators in the reflection counterparts. So we can just simply copy them. Oops. Oh, almost error there. And get 2 times NL times, oops, cosine. And cosine of L, so we can simply copy this. So there, that's our for our P. Same as before. L if then simply copy that to make our lives much easier. And simply copy this. Since from our pattern, we can see that the denominators of the transmission coefficient is equal to its counterpart in the reflection coefficient. Oh, yeah, I forgot. Else. Okay. Yeah. So let's try if our calculator works. So first make a linked space of our independent variable, which is our, let's try angle. So NP, that linked space. So from in the lab, so usually the angle is between 0 to pi over 2. So to simulate how the reflectivity test is done in the lab, we simply do 0 to pi over 2. There. Oops, sorry. So this is in rad. So we can now try to check if our plots are correct. So the reflection coefficient is sometimes complex. So to avoid this problem, we use the ab square. We use the ab square of the reflection coefficient. So let's try our calculator. Now try to use it for the P. Now in a single interface, I've discussed earlier that the N0 and NL are same. So let's try air. And our transmission is glass. wait. EOT is not defined. So I missed that part. Okay, let us see our plot. And again, we can, let's try for the S. And let's label them to make our lives. So we can understand more the plot. So label, so let's call this the S. Oh, sorry, P. Depolarized. And S polarized. There. Oh, yeah, I forgot. Sorry. TLT legend and TLT legend. Show. So there, that's our plot. So are you can you please thumbs up if you can if you followed? Okay, so there are some who okay, thank you guys. So we can try also water, just 1.33. There. So we can see that the reflectance, so the abs squared of the reflection coefficient is changing with the refractive index. So the abs squared of the reflection coefficient is actually called the reflectivity or the reflectance. So in studying in optics, this is very important. So how about if we try internal reflection? So you will study this in second year. So in total internal reflection, the first media is much greater than the second media. So zero. So we can see there's an error. Oh, wait. So yeah, I forgot to paste it in the copy paste board. Forgive me. Okay, now in the total internal reflection, or yeah, we can see that there's a error. So a trick here, if you're studying optics, you can simply add an imaginary number, which is, yes, it will still say an error, but we avoid so when we use this, we avoid the complex angle, which kind of ruins our plot a while ago. So this basically just says there's a zero imaginary number, then we get the correct plot. So how about for complex refractive index? So let's copy here. For complex refractive index, so I choose here silver. So in our reflectivity calculator, let's see if it will work. So this is the reflectivity of a air silver interface. Now we can move on to the transfer matrix, which we'll be using in modeling optical multilayers. So as you can see here, the transfer matrix is basically made up of two matrices. Here we will use the dot product. So Basically, the first matrix, called the transmission matrix, is actually composed of the reflection and transmission coefficient. And the second is the propagation matrix. And to get the reflectivity or reflectance, we simply get these elements. Oh, yeah. These elements from the transfer matrix. So let's try to make the transfer matrix. So we first start with beta. Oh, is my mouse not working? There, start first with beta. So we can see that we need the wavelength, which corresponds to the lambda in the expression. Then n 0, since from the Snell's law, nm, since you can see here. Now h corresponds to the thickness and the angle. First with beta. So return. Yeah, make it small. So as you can see, 2 times pi over the wavelength times the refractive index times h times cosine. Since a while ago we said before, we need to generalize it. So we go back, we find the inside. So we can see that here's the inside. Oops, am I correct? There. It's there. That's for A. It's for beta. Then we can now define our transmission matrix. So as you can see, the transmission matrix is actually made up of the reflection and transmission coefficients. So we can simply copy the parameters. Then we made a matrix, and so first matrix, say 2 by 2 matrix. Oh, yeah, correct. Yeah. Then one. So we made parentheses so to not be confused. One over D. So we can see transmission coefficient. Sorry. Transmission. You can all see that they're all divided by D. So we can actually just copy this and replace the one with selection coefficients. There, and we can see the selection coefficient. There we now have the transmission matrix. Now we can make the propagation matrix. So we can just simply copy this, since they're basically, propagation. There, made a matrix array. Now from here, we can see that we can now use the exponential we defined a while ago. Now to write a imaginary number as a while ago, we simply put -1j times beta. There and 0. And for the simply 0 and exponential we defined earlier. And we simply change it and we remove the negative. So I'll paste this in, I'll copy this into the copy paste board. Okay, can you please thumbs up if you follow the procedure? Okay, thank you. So now we can do a, oops. So now we can do a single layer thin film using the transfer matrix method. So we define M, which is for a single layer. Now we can see here are needed. So we need the mode and 0 and 1 and 2. Wavelength H, so we need H1, so which corresponds to 1 here, and our angle. Simply turn. Now we can copy our transmission matrix. Now put since a while ago and 0 and 1, sorry, and 2. Oops, my curve here. Oh, sorry, and 0 and 1. Dot product the propagation matrix. So simply copy this and 0 and 1 each one, and another dot product. Now here we can simply write 1, 2, which corresponds to this. Now to plot our reflectivity, make first the dependent variable. And we make an empty list. So in here, we're going to use a for loop. So why are we going to use for loop? So if we simply did a while ago, so if we simply put here the angle and try to plot here, the elements of the matrix will not match. So we use a for loop so that it will avoid that problem of not matching the matrix, the number of the matrix elements. So try here, for loop. So for each, wait, try to find the name theta in angle. Try to our empty list, we append, and we use this for a from the transfer matrix there. And from here, since we want to plot the reflectivity, so we get here. So in Python, it starts from 0. So one in Python, one in math is actually 0 in Python. So this will become, in this element becomes M1 0. So we get Python. Oops, forgot. One, 0. Divided by we go back here. So M11 becomes 00 in Python. So this is S. So let's denote RS as the activity as polarization. Now this becomes 0. There, another one in angle. This time for the depolarization. So let's write P. P. Now we have the, let's try that P. S. All right. Let's try it. Try it. If it will work. Oh yeah, sorry. Yeah, forgot to write. So we need the parameters. So let's go back here. Sorry, I forgot the parameters needed. So and 0, which is our first media. Let's start with 1. And 1 we go with glass. Oops, I have only 15 minutes remaining. Okay. And 2.0. Now the wavelength. So to simulate the wavelength used in the laboratory, so the wavelength we're going to use is 633 nanometers. So this corresponds to the wavelength used by the helium neon laser. And let's try to put 50 there. And let's see what will happen. So there, you can now see our error. So we can see that the shapes are not aligned. So that's why we have to make sure that the matrices align. So let's see, fix this. Give me a second. I'm sorry. So for the interruptions. So now we want the reflectivity. It's one before element. So we're gonna use another for loop. RP. Excuse. So we treat them as array. So we force Python to treat them as an array. So we write np that as array rs. Oops, sorry. RP. Then let's plot this. RS lt dot RP. Oop, what's our error? So we can, so there's a really an error here. Wait, just give me a second. Why, oh why? Why is there an error here? And 0 and 0. 1 and 0. 2. Let's try shapes. Huh. I think I missed something here. And the ouch. Okay, gets. So state that. Since we so when we use angle, it should be theta. Since it is inside our for loop. Theta. So there, that's the effectivity of a one layer thin film. So for a two layer, we simply just dot product. Simply copy this. Place it in N2. And we're gonna just copy this. So we're just gonna dot product with a propagation matrix and a transmission matrix. So we get this as 2, 3, and 2, 2. Now we simply add these parameters, h1, oops, h2, sorry. Then we copy this. Oops. Now we simply write N3. So which right now, this is to be 2, 1, water, which is 1.33, H2, let's try 50 nanometers. Right, N3, N3, H2, and H2, 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 and 3, and 3. Then we write, this is already a double layer. Simply write M2, oops, 2, M2. See if it will work. There. So when we tried to, let's say this is 1.5. And 0. So what we get when we set our thicknesses to both 0, we simply return to our there. So we simply return to the reflectivity in the single interface. So I'll try to write this in the copy paste board. Propagation matrix. Then for the single layer, and the double layer. So thumbs up, guys, if the code is already in the copy paste board. Okay, now we're done with the double layer thin film. Now let's try to make real real research is done. So I'm trying to find a paper here which shows they use this thin film. Can you see my screen? Can you please thumbs up? Okay, so can you see the anti-reflection coatings? Here, so we're gonna try to replicate this. So so we have to make, so as you can see, one, two, so it's actually a 3-layer, and this is the what's called the substrate. So we can make a 3-layer here. Now simply copy this, since it's our 3rd layer. There, 3, 3, 3, and 4. Simply add. So simply put this stop and 4. H3. There. Excuse. So we get M3. Let's change this. M3, M3, M3. Let's add N4 equals to something, H3. So we get, so this is the values that we're gonna use to replicate this research. So what am I missing? Oh, there, N4, H3, N4, H3, H3, H3. So we get our first one. So let's set this to 1.38. Response here, 1.38, 1.67, 2.43, and 3.89. Now we get the thickness, 3.5, 39.8 nanometers, and 51.6. Angel. Wait. All right, I forgot to write N4. So we can write, so let's try 500 nanometers. Huh, wait. See why it's not working. H3, no, 1.6. Huh. 500. Wait, it's figuring out why. Yeah, seems to be a problem here. Okay, N0 and 3. Why? Okay, so wait, I think I just missed something here. So trying to figure it out now. Sorry, guys. 3 point. Okay. Ayan, sorry. Yeah, so wait, let's try. 8 degrees. Angle. And, oh, where did I, shucks, where did I, oh, shucks. Sorry. Why is it not working? Patient and 0 and 1. 1, 2, 2. Two, three. Why, oh, why? Okay. Huh. Okay, let's just move on. I'll stop now here. I'll just send to the okay, I'll try to ano muna. Let's see na. Ating.
Hello. I think
Sorry.
there are
I'm
some.
sorry.
Okay.
Yeah.
Yes.
Get. Sorry, guys.
It's okay po.
Yeah, so things. Why, oh, why? So, let's change the things. Ano ba yung nangyari? Bakit kaya may mali? Huh. Magana naman siya. Okay, wait lang. Yeah. Saan na yung... Okay. I'll just send to you. Okay, fine. Why, oh, why? Why, oh, why? Kainis. So, I'll just send it to you, the, nag-resume na ba? So, yeah. So, currently, I found a problem here. So, I'll just send to you the code if you're interested. I'll try to correct this later, or I'll send it to the GC. Then I'll focus now on the next part. Sorry. So basically that's the problem with coding. So now you know how to make the transmission matrix. So I'll send to you the correct one. So basically this is the isotropic homogeneous transfer matrix. So it's basically only used for flat. Can you see my screen now? Can you please like? Okay, thank you. So basically the one we made is only for flat surfaces. Now there's many more modifications. So you can use the you can make a transfer matrix for the rough surface. Now in my research, we actually made for fractal materials. So basically these are materials that have non-integer dimensions, as you can see. So yeah, example, the Sierpinski triangle. And for 2D materials, which are basically graphene, so which are atom thin materials. So if you're not interested in optics, the transfer matrix can also be used in quantum physics. Now in quantum physics, since we derive it from the Maxwell equations, our transfer matrix, you can use the transfer matrix in quantum physics by simply changing it to the Schrodinger equation. So the transfer matrix in quantum physics is basically same to the optics there. So a recap. So we made matrices using NumPy, and we graph the Fresnel equations, and we code the transfer matrix. Unfortunately, the code is having an error right now, and I have a few time left. So that's all. Thank you for listening.
Yeah, so thank you, Kuya Steven, for that, of course, educational discussion. Yes. Of course, I think our participants also have questions for our speaker. So if you do have, please click the raise hand button and wait for us to call your name. So you may also type your question in the chat box, and we will read it to Mr. Steven. Mhm. Yeah, so maybe since we're still waiting for some questions to be asked, so how are you feeling, Franchesca?
Admittedly, I'm a little confused. I see the underlying principles between them. It's mostly basic uses of functions and matrices, but I really don't know what the equations are doing. How about you? You're ahead of me. Maybe you understood it a little better.
Actually, since Kuya Steven said that we will encounter some of the topics on our second
semester.
Yes, in our second semester this year. Of course, I'm also confused, but I'm also excited to meet those topics.
I wish you luck
as
when
we
you
go.
get there then.
Thank you, thank you. Yeah. So, are there anyone who have any questions to our speaker? Yes.
There don't seem to be
So
questions
also
on Facebook.
from our Facebook Live.
There do not seem to be questions on the Facebook Live.
Yes. Okay. So maybe I would also want to hear Kuya Steven answer from my question to Arianna earlier. So I asked Kuya Steven po, I want to ask what would you recommend for us to study on our own after your discussion po?
Yeah, so sorry for the nag-error kasi. Sorry.
Okay lang po. That
So,
really
you can
happens.
most of these topics you'll actually learn this in third year, second sem.
Yes
So,
po.
So
yeah.
best of luck.
So, yeah. So it's but actually the one I will show you should be it's actually it's very interesting for me because using optical multilayers you can actually model the surfaces of so a while ago our example should be our second example should be the reflectivity or why the color of a jumping spider is the way it
Ooh.
is. Yeah,
Ooh.
so I'll send it to you later. So yeah, it's kind of disappointing in my part. Sorry, guys.
Yes. Unfortunately, we didn't yes see it also. Mhm. Yes. So are there any questions from okay
I have a
from
question.
oh,
Honestly,
okay.
actually, um, how uh, how, uh, how do you? I'm trying to put it into words. How do you suggest we prepare for handling topics like this? Going from the basics of Python that we learned on the day one and also the earlier lecture. How do you suggest we study going forward so that we can handle more complex equations in Python?
Similar. You must start first with the basics, and of course, the physics is very important. So sometimes Python
I
gives you an answer, but it's wrong physics. So you should both balance the basics in coding and the basics in the theoretical part in the physics part.
Mm, okay, yes. I think of like that as well. Okay, so I think in our chat box there's a question from
Oh.
Clark Argarin. Yeah, so I will read it po. Ano po yung ibang operations na magagamit for matrices maliban sa mga example?
There's transpose. Yeah, you can do transpose, and yeah. So basically, NumPy is made for matrices. So there's tons of operations that you can do to matrices, except addition, subtraction, cross, and dot products.
Mhm.
Hmm.
Okay.
Okay. So what's in okay. Okay, so if there are no more questions, it doesn't seem like there are. Now that we've covered all of our questions, it's great. It was a very interesting lecture, and we hope that everyone had fun with it. But before we wrap up the program, we would actually like to invite our research extension and development chairperson, Mr. Paulo Medina, to deliver some closing remarks. Oh wait, last minute question is that allowed?
Yes.
Okay, a last minute question by Rajan Estabilio. He asks, pwede po ba gamitin yung Python for complex functions?
Yes, you can. Like a while ago, you can actually input imaginary and complex
Shush.
numbers in
Yeah,
the
sorry.
in Python. Yeah, so you can.
Okay. Would that be all? Are there any more questions remaining? Okay, so is that all of them?
I think that's all of them.
I think that's all of them. Okay, back to what was happening earlier. Now that we've covered all our questions, and before we wrap up the rest of the program, we invite our research extension and development chairperson, Mr. Paulo Medina, to deliver the closing remarks.
Hello? Hello? Hello?
Hello po.
Yan, okay. And I'll just have a short closing remarks lang. So for this day, I would like to thank, most importantly, si Kuya Steven and Ate Arianna for their knowledge and imparting their knowledge in Python para sa ating kailangan na matutunan. So basically sa introductory. So yung Python, magagamit natin siya most likely sa research natin, yung mga gusto gumawa din ng research dyan. And lalo na ngayon, online, most likely for computational ang mga magagawang research natin sa physics. And I think yung na-impart sa atin na knowledge ngayon ni Kuya Steven and Ate Arianna will likely help us more into our program sa physics. And yun lang, and it's a great day. Nagkaroon lang tayo ng mga konting technical difficulties, but it's still a great workshop for today. So, yan. Thank you, everyone.
Yeah, so thank you rin po for that wonderful remark. Okay, so before we end the program, of course, we would like to invite everyone to open your camera for the documentation. Of course, we would also like to see your beautiful faces. Right, partner?
Yes, accompany us.
Yeah, so again, okay, we invite everyone to open your camera for the documentation. Yes. Yes.
Sinong kumukuha?
I think you will have a lane for the documentation.
Pa-count naman. Para
Okay, sige.
honestly ako.
Sige, ayun. Smile tayo. 1, 2, 3. Wait lang. Send ko lang po Wait lang po. Wait lang po Wait lang, bagal po Wait lang po.
Oh.
Sige, si Wismar na lang po.
Yes.
Okay, page 1. Ready, 3, 2, 1. Smile. Okay, for the page 2, kahit walang mga camera. 3, 2, 1. Smile. Ayan. Thank you for your cooperation sa document.
Yeah. Yes. So I'm very happy to see the faces of the physics tips. Yeah. So again, we would like to express our sincerest gratitude to the speakers, Ms. Arianna, and also Mr. Steven, and also to Sir Nene. Yes, and also to the organizers of the event. Yes. Okay. So maybe thank you all, physics peeps, for your interest and your active participation in our program. So thank you po. Thank you po. Have a great day po.
Thank you for attending, everyone.
Yes,
Bye.
Thank you.